Following is an illustration of the apparatus to explain cathode ray propagation. The first component is a closed glass tube. The air inside has been pumped out, so that the tube is empty or has very low air pressure. It can also be called a gas discharge tube. The metal plate on the top is connected to the negative pole of the DC voltage source, called the cathode. The metal plate at the bottom is connected to the positive pole of the DC voltage source, referred to as the anode. Inside the tube, there is a cross-shaped barrier maltase. It also made of metal plates. When all electrical circuits have been connected and turned on, at the end of the tube opposite the cathode, it glowed greenish. But strangely, the glass in the form of cross maltase is clean from luminescence. Why does this happen? To explain this phenomenon, we will place three components, namely, a light source, a barrier, and a screen. Since we cannot see the movement of the cathode ray directly, we will take three assumptions. The first assumption, a parabolic ray. It turns out that on the screen almost all parts can be reached by the light. The beam can easily turn past a barrier. This is not in accordance with the results of observations. Thus, the cathode ray does not move in the parabolic path. The second assumption, the path of the ray is a sinus or cosine. Almost the same as the first assumption, almost all parts of the screen can be reached by light, especially if it has an amplitude exceeding the height of the barrier. This is not in accordance with the results of observations. Thus, the cathode ray does not move in the sinus or cosine path. The third assumption, the path of the ray is a straight line. This is consistent with the results of observations. Thus, the cathode ray moves in a straight line. Yup, I hope this tutorial can provide useful benefits. And don't forget to like, share, and subscribe.